Hi students, in the previous few videos, we have been seeing about fundamental theorem of arithmetic and using this theorem how the factor trees are getting generated. In this session, we are going to see how to use this theorem to generate HCF of two numbers. So let's start with two simple numbers, say 18 and 24. So, the fundamental theorem of arithmetic states that any composite numbers can be expressed as product of primes. So, here also we are going to do prime factorizations of 18 and 24, and then we are going to calculate HCF out of that. So, let's do the calculation for 18. So, we start with the smallest prime number 2, gets us a 9. So divide by 3 gets another 3, which is divided again by 3 to get a 1. So 18 can be expressed as 2 into 3 into 3. Now let's repeat this process for 24. So again starts with 2, gets us a 12, divide by 2, so you get a 6, divide by 2 again, we get to have a 3. So divide again by 3 to get the 1. So now 24 can be expressed as 2 into 2 into 2 into 3. Now we can pick factors that are common to both. So there is a 2 that is common to both. Then there is a 3 that is common to both. So I can write HCF of these two numbers is going to be 2 into 3, which is equal to 6. Okay. So now we'll try an experiment with a slightly bigger number, say 40 and 36. So let's take 40 and 36 and perform fine factorization. So 40 again starts with 2, we have a 20, divide by 2 gets a 10, divide again by 2 we get to have a 5, so close off with 5. Now we'll do the same process for 36. It is going to be division with 2 again, fetching an 18. Now I can take this and write this back. So I get a 9, divide by 3, 3 again, and 1. So now I can write the factor 40, the composite number 40 as 2 into 2 into 2 into 5. Now let's do the same thing for 36. It is going to be 2 into 2 into 3 into 3. So let's pick the common factors. There is 1, 2 here, 1, 2 here. There's another 2 here, other 2 here. So there are no more common factors, which means HCF of 40 and 36 is 2 into 2, which is 4. Now, let's try this whole process with a slightly bigger number. Let's say 72 and 120. So let's calculate and see how 72 and 120 can be expressed as prime numbers and then calculate HCF. So let's do prime factorization of 72. 72 is division of 2 is 36. Divided by 2 you get 18. Divide again 9, 3, you get to have 3, close off with 3. So 72 can be expressed as 2 into 2 into 2 into 3 into 3. Now let's repeat this one for 120. So in 120, again I start with 2. Please note that all the numbers that you get to do have to be prime numbers only. So I can't start with 6 or 12 or 10 even if the numbers are bigger. So 120 divided by 2 fetches a 60. Divide again by 2 gets a 30. Again by 2 gets 15. Now I can say 3 or 5, whichever is right. So 3 means 5 sa, so 5 ones are. Now I can write 120 as 2 into 2 into 2 into 3 into 5. Now let's pick the common factors. So there is one batch of 2 that I can pick, another batch of 2 I can pick, another batch of 2 I can pick, and one more batch of 3. So HCF in this case is 2 into 2 into 2 into 3. 2 into 2 is 4, 4 into 2 is 8, 8 into 3 is 24. So HCF here is going to be equal to 24. Now let's try the same thing for practice with another bigger set of numbers. So in this case, the numbers are going to be 510 and 92. Okay, so 5, 10 and 92. I picked these combinations from your textbook. So it is a textbook sum that I'm going to work out here. So let's start for 510. It's going to be divisible by 2. So 255 times. I'm going to divide this by 5. Fetches me a 51. 51 means 5 plus 1 is 6. So it's divisible by 3. So if I put 3, it is going to get me a 17. We know 17 is a prime number. So I have to divide it with 17 and close this off. So I can express 510 as 2 into 5 into 3 into 17. Now let's do this for 92. Again, I'm going to start with 2. So this is going to fetch a 46. I'm going to divide again. This is going to get me a 23. So 23 is a prime number by itself. So I'm going to divide by 23 and stop that. So 92 is equal to 2 into 2 into 23. Now if I pick the common factors, there is only one common factor between them, which is 2. So in this case, HCF between these two numbers is going to be just 2. So like this, you can find out the HCF between any two numbers using prime factorization. Okay. See, for more practice questions and custom question papers, please feel free to reach out to my website www.smartlylearn.in. Also, please extend your support to me by subscribing to my channel. See you in the next video. Bye.